Compound interest. To find the compound interest, the final balance of your account, which we're going to call A, is going to equal the principal, that's the amount of money that you invested, and we're going to call that P, times the sum of 1 and the interest rate as a decimal, we're going to call that R, divided by C, where C is the number of times it is compounded per year, to the T, which is the time in years, times C, which once again is the number of times it's compounded per year. It's extremely important that this time is measured in years. It's extremely important that the interest rate is a decimal. All right, number 7. If $2,000 is invested, that means that P is 2,000, at 4% annual interest, that is R, but you got to write as a decimal, compounded quarterly. There are 4 quarters in a year, so that means that C is 4. What is the balance after 9 months? 9 months is not in years. To change months to years, you divide it by 12. That's 3/4 of a year. Compound interest formula, A equals P times 1 plus R over C times T to the C. If we plug these numbers in, 2,000 is what P is. Interest rate is 4% as a decimal, that is 4/100. C, it is compounded 4 times a year. T is, boy, my handwriting up there is just atrocious, is 3/4 of a year. And C, once again, is 4. Simplify this somewhat before you put it in your calculator to avoid calculator problems. The exponent, 3/4 times 4, the 4's cancel when you get 3. Inside the parentheses, 4/100 divided by 4 is 1/100. 1/100 plus 1 is 1 1/100. Put that in your calculator. This is going to come out to be approximately $2,060.60. Got to round the 2 decimal places because we're talking about coins, change. Number 8. If $12,000 is invested at 8% annual interest, compounded semi-annually, what's the balance after 1 year? So P is 12,000, R is 8%. Semi-annually means 2 times in a year, so C is 2. What's the balance after 1 year? So that's T. So this is pretty explicit what we're supposed to do. Get this formula. Doesn't matter the order that the C and the T are in. So we got $12,000 times 1 plus the interest is 8/100 divided by C, which is 2, and then C is 2 times 1. Simplify this a bit before we put it in our calculator. 8/100 divided by 2 is 4/100, plus 1 is 104/100. 2 times 1 is 2. Put this bad boy for life in your calculator. You're going to get $12,979.20 around the 2 decimal places because we're talking about money. Mixture problems. These are actually from Algebra 1, but don't let that fool you. These are not simple. A dealer wishes to mix 20 pounds of coffee selling for $4.50 per pound with some more expensive coffee selling at $6 per pound to make a mixture that will sell for $5 per pound. How many pounds of the more expensive coffee should he use? We're going to make a table for this. We have the original amount, the original coffee. We have the expensive. We're going to put those together and get a mixture. So that's going to be the horizontal part to our table. What other things do we have? We got pounds, we got the number of pounds, and then we have what they're charging per pound, so dollars per pound. And then we have the total cost. Seems logical, right? If you have a certain number of pounds and the dollars per pound, you want to know what your total cost is going to be. So let's fill in the table with things that are facts. 20 pounds of the original coffee. 20. It's $4.50 per pound. 4.50. So that's done. With some more expensive coffee that sells for $6 a pound, we don't know how many pounds that is, to make a mixture that will sell for $5 a pound. So the mixture is going to be $5. So then the question is, how many pounds of the more expensive coffee should he use? We don't know that. We're going to use a variable. So if you look at this column here, we got 20 pounds. We're going to add to that a mixture that is X pounds. Well, that means that the mixture is going to be those added together, 20 plus X. Column on the right, the total money, if you take pounds times money, that gives you the total money. So 20 pounds times 450, it's $90 large. X times $6 is going to be 6X. And then for this third, this guy down here, this is the most crucial part. We can find this in two ways. We can take the money from the original and add the money to the expensive, and that's going to be 90 plus 6X. That seems logical to put in that box. What also seems logical is to take the number of pounds of the mixture times the dollars per pound and also put that into the box. What that tells us is those two things are going to be equal to each other. So we got 5 times 20 plus X has a logical reason for being in this box, and 6X plus 90 has a logical reason for being in this box. So we're going to set those equal to each other since they're two things that are referring to the same amount. We're going to solve the equation. That'll give us X, and we defined X earlier as the number of pounds that are in the expensive coffee. If we distribute the 5, we're going to get 100 plus 5X. If we subtract 5X from both sides, we're going to get 100 is 6X plus 90. If we subtract 90 from both sides, we get 6X is 10. I made a mistake. If we subtract, let me go back a step. If we subtract 5X from both sides, we're going to get 100 equals X plus 90. If we subtract 90 from both sides, we're going to get 10 equals X. That means they should add 10 pounds of the more expensive, and that would make sure that your coffee mixture is $5 per pound. Number 10. How much water must be added to 20 gallons of a solution that is 30% alcohol to dilute it to a solution that is only 25% alcohol? Once again, this is not an easy problem. If you set up a table, it makes it easier. Get three things. That's why there's 3 rows. We have how much water should be added. So we're going to add in some water. To a 20 gallons of a solution. So we have the solution, we're adding water to it. That's going to give us a mixture. So what's going to go across the top? We got gallons. And then we have percent alcohol. Now this right column is going to be the total alcohol. So let's fill in what we know. We know that we're going to, it says how much water will be added, so we don't know how many gallons of water. It's an unknown. we do know our unknown, which is an oxymoron, 20 gallons of a solution, that is 30% alcohol. When you put percents into equations, use the decimal equivalent. To dilute it to a solution that's only 25% alcohol. So our mixture, we want it to be 0.25. Now we're not told this, but what percent of water is alcohol? If you've studied basic rocket science, you would know that the percent of alcohol in water is 0%. So we have a similar situation than we were from the coffee problem. To find the total alcohol, we're going to multiply the gallons times the percent that's alcohol. So 20 times 3/100 is going to be 6. X times 0 is going to be 0. We got 20 gallons of solution plus X gallons of water. That means that we're going to have a mixture that is 20 plus X. Now this last box is the most important. This is where our equation comes from. It's going to be found in two ways once again. If you take the total alcohol that's in the solution plus the total alcohol that's in the water, that should tell you how much alcohol is going to be in the mixture, which is 6 plus 0, which of course is 0. Similarly, if you take the gallons of the mixture times the percent that it's alcohol and multiply those together, that's going to give you the alcohol total in the mixture. Once again, we get two different things that are equal to each other. So you set them equal to each other. If you distribute the 0.25, if I subtract 5 from both sides and divide both sides by 0.25 or multiply by 4, same thing. Make sure we answer the question. How much water should be added? X was the gallons of water. We should add 4 gallons of water. All right. That's all, folks.